Hello students, myself Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the question bank tutorial on the Green Chemistry and Fuels module. So the first one is explain about the phase transfer catalyst method with examples. So this is like there are different methods that are used in the green chemistry for the synthesis that uses the safer solvents and all. So here is one of the method wherein phase transfer catalyst is used. Whenever there is immiscible solvents are present but we need to carry on the reaction, then we use this type of catalyst. So in phase transfer catalyst system, which are biphasic in nature, usually an aqueous phase containing one of the reactant is in contact with organic phase containing the other reactants. So they transfer between these two phases, and the reaction proceeds. This is how the reactions which are not feasible are also made to react with the use of these phase transfer catalyst. So here if you see there is cyanide ion, so here RCl is used and that becomes RCN because there is a transfer of this ion into the organic phase and helps in the reaction. So this is how the quaternary ammonium salts will help in the reaction process. So next is the why is net calorific value less than gross calorific value. So if you see the calorific value is two types, net calorific value and gross calorific value. So gross calorific value is the total heat that is liberated including the heat of steam also. So net is nothing but the useful calorific value that is available for the running of machinery or the energy. So this is because net calorific value will be lower because the latent heat will be removed, or the heat due to steam will be removed from the gross calorific value. That is why the net calorific value will be lower. So this is because net calorific value is the quantity of heat produced by combustion when water produced by combustion remains gaseous. So since water releases heat when it condenses, GCV is clearly bigger than NCV. So whenever NCV is there, GCV is subtracted with the heat of steam. That is present because of moisture in that particular fuels. So this is very important factor for any fuel before we decide and use it for the application purpose. Next question is list the various steps involved in the refining of petroleum. At what temperature kerosene, diesel and gasoline are obtained? How do they differ in their composition? So if you see here, there is some processing. So the the crude oil is the what we obtain from the earth crust. From the earth's crust or the fossil fuels. So fossil fuels are present. So that is the crude oil. So before we use it for any of the purpose, it must be refined. So for that we use refining of petroleum, that is the fractional distillation procedure. Fractional distillation. So this is the procedure wherein we subject to heat. So this crude oil is sent to the heating chamber and fractions increasing in density and boiling point are obtained. So the density will increase. And also boiling point. Fractions decreasing in density and boiling point. So wherever we see the crude oil is first sent heated so that we get the different components that are present in the raw oil or the crude oil obtained from the earth. So here we have different steps like distillation and separation. So distillation is the process wherein we send the crude oil, and separation is depending on their boiling point and density. Separation takes place. So in the first step, this is what happens, and then conversion or upgradation. For example, we have very heavy oil. So heavy oil, they cannot be used as such. So they will be converted to some useful products product so that they can be converted into lubricants, waxes, and then can be used for any of the polishing purpose or for the machineries for lubricating. So this is how we use the different types of components that are obtained from this process. So we need to convert and upgrade to some other process or some other material or the compound that is obtained so that it will be useful for the application. So this is the second step. Then desulfurization or sweating. So this is nothing but the removal of sulfur. Removal of sulfur. So whatever we obtain, the crude oil will contain everything. So the removal of sulfur is done, and this sulfur is supplied to fertilizers in the manufacturing of fertilizers industries, because it contains the pure sulfur that is present, so that can be supplied to the industries to manufacture fertilizers. In this way, we have 3 different steps that are used in the refining of petroleum. So if you see here, these are the C20 to C70. This is nothing but the carbon chain that is present for that particular compound, and this is C20 to C50. So whenever it is very heavy, the temperature is also high. So the temperature is around 600 degrees centigrade, and it is a fuel oil, and the residue will have greater than C70. That is why it will be like very thick present. So bitumen are very thick that is present. The example tar that will be used for laying roads. So next is the diesel oil. So the boiling point will be less. So it is 270 degrees centigrade and has the carbon chain between C14 to C20. That is used as a diesel oil for the running automobiles or train fuel, mostly for the running trains. Then is the kerosene, which has 170 degrees centigrade for the boiling point with C10 to C16 carbon chain, and jet fuel used for jet fuel and also for domestic purpose. Then petrol 120 degrees centigrade for gasoline usage, automobiles and all. Naphtha, which is 70 degrees, highly volatile, so naphtha 70 degrees is used in the chemicals. Then 20 degrees LPG gas. So if you see the boiling point is decreasing and also the density will increase. So this is how there is always formation of many fractions from this, or the components are forming from this process, and the distillation is used, that is nothing but the fractional distillation. And we have 3 different steps, that is distillation and separation, then conversion or upgradation, so that we will be using for the applications. Then desulfurization, removal of sulfur, and use it for any of the applications. So that is how we need to give an explanation how the distillation or the refining technique is used to obtain petroleum. Next, we also have the formula numerical problems in this unit. Numerical problems for calorific value. So we will see some of the numerical problems. A sample of coal has following composition on mass basis. Carbon is 76%, hydrogen is 5%, sulfur is 1.5%, oxygen is 8.5%, and ash is 7%. So if you see here, ash is forming, and oxygen is there, and also hydrogen is there, and sulfur is there. So we will be using a formula for the HCV and LCV, that is higher calorific value and the lower calorific value. Now calculate the higher and lower calorific value per kg. So whenever we are asked in report in per kg, we have to convert and report in the per kg. So given composition of the coal on mass basis, carbon is it will be 0.76 because it is 76%, and hydrogen is 0.05, and sulfur is 0.01, oxygen is 0.08, and ash is 0.07. Now we will be using the Dulong formula. A scientist who has proposed this formula for the higher calorific value, wherein a constant is given for each of these elements. So 33,800 carbon plus 144,000 multiplied by hydrogen content minus oxygen by 8 plus 9270 into S, that is sulfur. So sulfur, this is hydrogen, hydrogen, this is oxygen and carbon. So these are the main constituents that will contribute to the calorific value of that particular fuel. So we take only those values and substitute in this formula. So 33,800 into 0.76 for the carbon and 144,000 into hydrogen is 0.05 minus oxygen is 0.085 divided by 8 and into plus 9270 into 0.015. This is for the sulfur. So then after simplification we get 31,497.05 kilojoules per kg. So whenever they are asking for kg, we have to use this formula and substitute the values accordingly. And if you see, the LCV is given by HCV minus 9H2 into 2466 kilojoules per kg. So substitute the HCV value here, minus 9 into 0.05 for the hydrogen into 2466. So after simplification, we get 30,387.35 kilojoule per kg. So if you see here also, the net calorific value or the lower calorific value is lower than a higher calorific value because we are subtracting the latent heat of steam. So this is the value for the latent heat of steam. 9H2 into 2466 is the latent heat of steam that is present already in that particular fuel sample. So we need to subtract that because the lower calorific value or the net calorific value is the contribution of energy that is obtained just because of other elements, the carbon, hydrogen, oxygen, sulfur, and subtracting or removing the latent heat of steam. So therefore, we remove it this way and we get in the kilojoules per kg, which is always lower than higher calorific value. Next, calculate the HCV and LCV of a coal sample from the following data per kg of coal, wherein carbon is 70%, so 0.770 carbon, and hydrogen is 6%, oxygen is 8%, sulfur is 5%, and remaining is ash. So ash is not contributing to any of the energy, so we need not consider for that. So to calculate the higher calorific value and lower, we need to use the Dulong's formula, which is given by HCV is equal to 33700 in percentage. So whenever it is given, like we can substitute in percentages also. So 144,200 into hydrogen in percentage plus 39300 into sulfur percent plus 2250 into oxygen in percent minus 6100 kilojoule per kg. So whenever we are taking in percentages, these values will be changing. So we need to either remember one of the formulas so that we report in the kilojoule per kg. So now substitute the values of carbon 70 and the hydrogen 6, oxygen, sulfur and oxygen values also 8 and 5, sulfur and 8 for the oxygen, and we get the value 31,323 kilojoule per kg. So this is the value for GCV or HCV. Even if it is GCV or HCV, it is the same thing, gross calorific value or higher calorific value. Next, LCV is HCV minus 584 into 6% is nothing but the hydrogen by 8. So this will remove the steam. So we are removing the steam value. So 31323 minus this will give 29,992 kilojoule per kg. So again it is very less. LCV is less than HCV always. Next, what is a fuel? Classify fuel with suitable examples. So fuel is nothing but a combustible substance which on burning will give a large amount of heat or energy which can be used for economically, like for domestic and industrial purpose. So fuels are in general like natural fuel is already present, and secondary is the derivative of natural fuel or the artificial fuel. So primary, it is also called primary fuel for the natural fuel, and secondary fuel is like artificial fuel. So natural fuels, for example, solid examples are wood, coal, liquid is petroleum, gaseous is natural gas, and the artificial fuel charcoal. For solid state it is charcoal, liquid petroleum. So from the crude oil, petroleum is obtained, and the gas is coal gas that is obtained from the coal processing. Next, explain how the percentage of carbon, hydrogen, sulfur and oxygen is estimated by ultimate analysis of coal. So we have like analysis that to be done for any coal sample before we give a ranking to that ranking of coal. So we have several aspects like proximate analysis and ultimate analysis. In ultimate analysis, we do for carbon, hydrogen, sulfur and oxygen. Carbon, hydrogen, sulfur and oxygen analysis for that particular coal sample. So we will see how it is done. So for that we have to even do the proximate analysis also. So we have to also do the proximate analysis. So let us first see how the proximate analysis is done. So in the proximate analysis we have moisture, volatile matter, ash content and fixed carbon. So sometimes they also ask like in different way, like different question, like only proximate analysis wherein moisture, volatile matter, ash and fixed carbon should be mentioned. So this is the procedure for the moisture. So in moisture what we do, we heat the coal sample for about 100 degrees centigrade. So what is the boiling point for water? It is 100 degrees centigrade. So any type of moisture that is present in coal will be evaporated at this temperature, evaporated at 100 degrees centigrade. That is why we use or heat at 100 degrees centigrade for approximately 1 hour. So then we weigh the sample, like before weight if it is W and after heating if it is X, then this is the X sample, that is the weight of the sample after the removal of moisture. So the percentage of moisture is given by weight loss by sample weight into 100. So that will give in the percentage. Because we are multiplying with 100. Then we have volatile matter. So in volatile matter we will be doing the volatile matter will be removed by heating it at some temperature. So in this we have sample X. So we have removed the moisture in that. So the same sample will be used here. So the sample X grams from moisture step is taken and then heated at 950 degrees centigrade for 5 to 7 minutes. Only for 5 to 7 minutes, and that will give a weight of Y grams. So this is the weight that we obtain after the removal of volatile matter. So any volatile matter will be removed at this temperature and duration. So once we get this, we will be volatile matter percentage is given by weight loss by sample weight into 100. So that will give the volatile matter percentage. Okay, then we do the ash content. So in ash content, we take the sample from the volatile matter. So this is from the moisture step and this is the volatile matter, Y sample from the volatile matter. This Y grams is again taken and then heated at 750 degrees centigrade for 1 hour. So because it has to be ashed properly, so we use here 750 for heating at 750 we use muffle furnace because high temperatures. So we have to heat the sample at 750 degrees centigrade for 1 hour and we get some grams, like weigh it again for consequent readings and we get Z grams. Okay, so this is the content of ash. So how do we get ash content now? Ash, weight of ash left over left over by sample weight. Sample weight is the weight we get it here into 100. That will be the ash content. Okay. So then we have the fixed carbon. After removal of everything, the carbon that is present is nothing but the fixed carbon. So 100 minus moisture plus volatile matter plus ash will give the exact amount of fixed carbon, that is non-volatile carbon. Even after any treatment, there is no removal of carbon at all from this. So this is the fixed carbon that is present in that particular fuel. So carbon is the main component that will be in combustion reaction. So that is why fixed carbon is also an important parameter. So 100 minus all these, sum of all these will give us the fixed carbon percentage. So this is how we do the proximate analysis or the preliminary analysis for any particular coal sample. So let us see in detail the formula also. So if you see here, I've already written, but this is percentage of moisture, loss in weight before and after the heating by weight of the coal taken into 100. Then this is the x grams. Okay. Then percentage of volatile matter, loss in weight due to removal of volatile matter by weight of the sample into 100. This is the y grams. And percentage of weight of ash left by weight of coal sample that is taken initially into 100. This is z grams. So the percentage of fixed carbon is 100 minus sum of all these will give the percentage of fixed carbon that is really available for the combustion. Okay, so this is the proximate analysis. Now let us look into the ultimate analysis of that particular coal sample. So for that we need to carry on this test for carbon and hydrogen. For carbon and hydrogen, the combustion method is used wherein we take carbon in a crucible and subject oxygen, pure oxygen is sent. Okay, whenever pure oxygen is sent, the burning is burnt in the presence of pure oxygen. So the oxygen whenever is sent, the carbon dioxide and the water vapor that is coming out from this coal sample will be absorbed with calcium chloride or magnesium chloride and KOH solution. So there is nothing but the weight we will be taking. So before and after rates of this calcium chloride and KOH sample, so that will give the absorbing of carbon dioxide and moisture that is present. That is because of hydrogen that is present. So if you see the method, like known weight of coal is burnt in the presence of pure oxygen. So the carbon dioxide and water produced passed through tubes of calcium chloride and KOH. Anhydrous calcium chloride is like no water present. So if water is already present, hydrated salt if we use, what happens? There will be error result because already water content is present. So we have to use only anhydrous salt. Anhydrous calcium chloride must be taken in a bent tube, and KOH solution is also taken. So the increase in weight of calcium chloride or KOH is due to absorption of water and carbon dioxide. So if there is, it is always have the possibility of absorbing because it is not having water molecule here. So the calcium chloride will always tends to take up the moisture. So that if at all is present, the hydrogen content if at all is present in this coal sample, then it will obviously produce moisture because oxygen is present here, hydrogen plus this oxygen is present. So that will give rise to H2O. So this water, if it is forming, the percentage of water molecules or the moisture that is forming will be absorbed in this tube that is containing calcium chloride. Obviously, whenever it is absorbing, the weight will be increased because now it is becoming hydrated salt, that is calcium chloride dot H2O. Before it is only calcium chloride. Now it is calcium chloride dot H2O, that is hydrated salt. It is becoming because of absorption of this water molecule. So then there will be definitely increasing the weight of this particular calcium chloride. That is how we will be determining the hydrogen and carbon content, wherein carbon dioxide is absorbed by the KOH. So this is how the carbon and hydrogen will be estimated using the formula. Percentage of carbon is equal to increase in weight of KOH tube into 12, that is the atomic weight of carbon, by weight of the coal sample taken. Weight of the coal sample taken into 44 into 100. Atomic weight or the molecular weight of this particular carbon dioxide. Carbon dioxide. Okay, so that is how this formula will be used. Percentage of carbon is equal to increase in weight of KOH into 12 by weight of the coal sample taken into 44 into 100. So therefore we get the percentage of carbon. Then for hydrogen, increase in weight of calcium chloride tube by weight of the coal sample taken into 18 and multiplied by 100 to get in the percentages. So that is how we get this is for hydrogen and this is for oxygen. Okay, and we get the percentage of hydrogen that is present in that particular coal sample, and this method is used for estimation of carbon and hydrogen. Now let us see how the sulfur and oxygen are estimated for in any of the coal for the ultimate analysis. So this method is used as ESCA method. So wherein the sulfur containing coal is burnt in bomb pot containing barium sulfate. So the sulfur dioxide. So whenever we are burning, there is always evolution of these gases, sulfur dioxide and trioxide, because if sulfur is present. If sulfur is present, when we are burning, definitely it will form sulfur dioxide because it is done in the presence of oxygen. So sulfur dioxide and trioxide is forming. So those are dissolved in water. And also formation of white precipitate of barium sulfate on the addition of barium chloride solution is forming. So we are also testing it with the barium sulfate solution upon adding to that water. So whenever water is containing plus this sulfur dioxide plus trioxide will form sulfuric acid. So whenever we are adding barium chloride to this, barium sulfate will form. So that will form the precipitate. So this is one of the identification test whether sulfur is present in that particular sample or not. So the precipitate of barium sulfate is washed, dried and weighed. So this barium sulfate is taken, dried and then taken weighed. So the percentage of sulfur is equal to weight of barium sulfate formed into 32 by weight of the coal sample taken into 233. This is the molecular weight of barium sulfate and this is for the sulfur, and into 100. Sulfur present in barium sulfate into 100, that will give in the percentages. So this is how sulfur is estimated. Very simple method wherein sulfur in the coal sample is tested. Burning in the presence of oxygen will give rise to sulfur dioxide and trioxide, and these sulfur dioxide, trioxide and dissolved in water will form sulfuric acid. This can be identified by barium chloride addition that forms barium sulfate. So we take that barium sulfate precipitate, dry and weigh it properly, and then we apply this formula. Using the weight of barium sulfate and the coal sample taken, the formation will be taken in consideration. Like the formation can be identified because if at all there is a lot of sulfur, then there is a lot of barium sulfate forming. Then percentage of ash. So this oxygen is generally removed during the test like proximate test and ultimate analysis. Proximate and ultimate analysis like carbon, hydrogen, sulfur. So in this we are doing moisture, volatile matter, ash and fixed carbon. So all these tests are done. So there is always scope of this oxygen removal in that. So therefore we take the consideration of ash. So weight of ash formed by weight of coal taken into 100. So whenever it is completely burned, we use this formula and subtract the other content so that we get the percentage of oxygen. Weigh the amount of ash that is left after combustion. So carbon, hydrogen, sulfur, nitrogen, ash. So all these tests will be done and subtract from the 100 and we get the percentage of oxygen. So this is how the carbon, hydrogen, sulfur and oxygen tests are done in the ultimate analysis. So before that we also have to do the proximate analysis because we have the ash content here considered. So therefore we have to perform both the test for any coal sample before we rank it according to the ranking that is present. Next, this is one of the long answer. Explain briefly the microwave method with example. So for example, conventional heating and microwave heating. In conventional heating, what we do is we take a beaker and heat the solvent or the any other type of material that reactants are present. So here what happens, the heat is coming from the outside, from the mantle. Heat is coming, so energy is coming from the mantle. Energy is given from the mantle. So there is always loss. There is always loss through before it is transferred. So it requires a lot of time. The time taken is more for the reaction to complete. Whereas in the microwave heating, it is in the enclosed apparatus. So the microwaves are sent directly are subjected to the solutions or the reactants that are present. So the molecules will vibrate. So the molecules will take part. Molecules will take part in the reaction. So within less time, there is a reaction taking place. So therefore, microwave method is most widely used in advanced today modern reactions because it takes very less time. Less solvent can be used and safer method because it is in the closed apparatus that is used. So conventional synthesis usually involves the use of furnace or oil bath which heats the walls of the reactors by convection or conduction. So this requires a lot of time because the vessel also gets heated before the contents of the vessel get heated. So the core of sample takes much longer time to achieve the target temperature. So this is a slow and inefficient method for transferring energy into the reacting system. Whereas on the other hand, microwave assisted synthesis, microwaves are used that penetrates into the material. So glass is transferred into microwaves so that penetrates into the materials, also Teflon. So and heat is generated through the direct microwave material interaction. So this microwaves directly interacts with the material and the reaction is faster. This is how very advantageous procedure that we use for the synthesis of any of the materials or products. So if we see an example, benzylidene diacetate converting from benzaldehyde takes longer time if we use conventional method. But in this case, we are, for example, microwave set. If it is subjected to microwave, it only just take 40 seconds. Within 40 seconds, we get the product benzaldehyde. So benzaldehyde is obtained in just 40 seconds. So that is very advantageous. So solvent-free techniques is also used because the solvent is like ammonia used here. So that can also sometimes replace the solvents and use only solid state reactions that takes place and helps in the safer methods. So solvent free technique hold a strategic position as solvent is very toxic, expensive. expensive and problematic to use and to remove. And also recycling of this solvent is also very important after its usage. So it is always like better to avoid these solvents. That is how the green chemistry works. So this is the main reason for development of such modern technologies, and these approaches can also enable experiments avoiding the use of toxic solvents and use the it will be more safe for the environment and also the person working with and also the reaction. So these acids can be replaced by solid recyclable acids such as clays. So this type of reactions are known as solid state reactions. So this is possible only because of microwaves. So if these solid state reactions are not feasible with the conventional method, whereas in the microwave method it is very much useful because it penetrates directly into the reactants and helps in the reactions procedure. So then next is the composition, properties and applications of LPG and CNG. Sometimes like the question will be both the LPG and CNG or LPG alone. So here they have asked for both LPG and CNG. So LPG is the liquid petroleum gas. Liquid petroleum gas. So it is a byproduct obtained from the fractional distillation of crude oil or by cracking of heavy oil, and it consists of propane and butane. It is the constituent of propane and butane, has the higher calorific value of 27,000 kilocalories per cubic meter and gives less carbon dioxide and unburned hydrocarbons. So these are the characteristics. From here they are the properties of this LPG. So it can cause less pollution, moderate heat which is good for cooking, and also storage is simple, colorless, tends to mix with air easily, and burning gives no toxic gases. Therefore, it can be used for the, though it is toxic, it is not giving toxic gases during cooking or like using for any of the purposes. It can neither give smoke nor ash content, and cheaper than gasoline, and can be used in the auto vehicles, dangerous when there is a leakage. So these are the various applications which can use it for the household use. For cooking that we use in our daily life is the LPG gas, then commercial use at restaurant or hotel, then bulk sale for the ship breaking industries, like for even for the running, and auto gas whenever we are using for the vehicles, we call it as auto gas. And textiles, and then glass and ceramic processing, iron, steel, like welding purposes, and aerosol purpose also, like for the refrigerants, because the other chlorofluorocarbons can be replaced with this LPG, because that is very toxic to the environment compared to this LPG. So therefore LPG is used in many of the applications and has wide usage. Then we will see the CNG. CNG is nothing but the natural gas that is compressed. So compressed natural gas, it contains mainly methane. About 90% is methane that is present, which is obtained from the natural gas, and is cheapest. Like these are the properties: cheapest, cleanest, and least environmental impacting. And then vehicles are powered mostly by CNG because it produces less carbon monoxide and hydrocarbon emissions. Then less expensive than petrol and diesel. Then it only requires some space for space in vehicles, because this is like CNG, it requires some tank or the space in that particular vehicle. So this is the only disadvantages. Otherwise the ignition time is also good and less expense. Temperature is good and less expense than petrol and diesel. So space is required for the vehicles. Ignition temperature is about 550 degrees centigrade and requires more air for ignition. So that is why it requires, because it requires more air for ignition, we avoid for the domestic usages, whereas we can use it for the automobiles and machineries. Automobiles and machinery are the wide applications of this CNG gas. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.